If you've been here 2 years ago, you might know already all the things about Bazel, but today we get again some updates from Andreas.
Very much. Thank you for having me. Brief introduction. Hi, I'm Andreas. I work at Modus Create, which is a global digital consulting company having a wide range of offerings from AI, product development, cloud, security, all these kinds of things. And I'm with the open source program office called Tweag. Check us out at tweag.io. We have some cool projects. And among them, we have a scalable builds group that works on scalable build systems like Bazel and Buck2 and can also help you migrate to those. So that's today's topic, Bazel, Buck, and friends, how to scale your builds. It's a high-level overview, so we'll have to move a bit fast. But first, let's start with the motivation. Why would we even care about our build systems? Well, it comes down to developer productivity and fast feedback loops, preventing office sword fights. I'm sure everybody knows here that XKCD comic. So we want our builds to be fast, we want our feedback loops to be fast during our development, and we also want our builds to be reliable to avoid the works on my machine types of issues, right? And so a scalable build system is one path to achieve that. So let me give a bit of definitions of what I'm talking about. So what do I mean when I say build system? In the simplest form, you could say it's whatever developers use to turn the code they write into some artifacts, like libraries, executables, Docker images, whatever it is that you're producing. So very narrowly speaking, it's sort of a compiler task manager, if you will. But of course, it's supposed to be efficient, right? We want to avoid redundant work. We want to avoid repeated work, unnecessary work. So tools that probably everybody here is familiar with are things like Make, Ninja, Maven, these kinds of things. But more broadly, it would also be nice if our build system could manage tasks like tests, for example, because if I don't change any of my test dependencies, then why would I need to rerun the tests? And builds is all about dependencies, so managing dependencies would also be a nice feature, and maybe even packaging. And then when I talk about scalable, what do I mean there? Well, if we look at Wikipedia, scalability is all about handling increased workloads, like vertical scaling, horizontal scaling, these kinds of things. But for build systems concretely, I want a build system to be able to handle a large and ever-growing code base, right? So if I make a change to my code base, I don't want the time it takes to rebuild to depend on the size of the overall code base, but only on the size of the change that I make. I also want it to be able to work for large teams. So if I have many developers in my team, I don't want to repeat the expensive build over and over again on every developer machine. I want to share this, have a shared distributed build infrastructure, shared cache. And as projects grow, they tend to grow in complexity. You end up with more programming languages involved, code generation steps, custom tooling, all this kind of stuff. So it needs to be extensible to capture these kinds of things. So in summary, for a scalable build system, we want that it supports incremental builds to efficiently manage our build and test tasks and things like this. It should be distributed to support large teams and large code bases. It should be extensible to support our complex ever more complex projects, and ideally also cross-platform use cases. And all that while having a fast feedback loop for our developers and being reliable. So let's give a brief history over these kinds of systems that are available in this space. So Google was facing these kinds of issues, and back in 2006, they started using their internal new build system called Blaze, which is meant to handle exactly these kinds of things, so large code bases, complex code bases, large teams. But it was only Google internal, and word got out, and people wanted to have these tools in other companies. So in 2012, Twitter and others open-sourced Pants, which is a build system inspired by Blaze, at the time primarily targeting their Scala code base, but also capable of other use cases. In 2013, Facebook published Buck, which is also a Blaze-inspired build system, initially targeting their Android use case, but also more general. Then in 2015, Thought Machine published Please, because they had some limitations that Buck found some limitations in Buck where it didn't work for them. And that was just before, also in 2015, Google then decided to open source Bazel, which is the open source version of their build system Blaze. And to give an idea of the kinds of scale that some of these systems can handle, around 2016, Google reported of having about 2 billion lines of code in their code base and 20,000 commits a day. So that's the kinds of scales that these systems can handle, or at least some of them. Since then, Bazel itself has gone through a bit of an evolution. So in 2019, we saw the release of the first stable version, 1.0, but it's seen many improvements since. In 2022, something very interesting in particular to the open source ecosystem happened, which is that they introduced a new proper dependency management system called Bazel Mod, which makes it much easier to depend on other Bazel projects within your Bazel project. So Bazel extensions, rule sets, but also other kinds of tools. So for example, there is a catalog of some C libraries built in Bazel. And that's become the default system in version 8 and is going to be the only option starting from version 9. In 2023, Bazel 7 modernized C++ and Android toolchains and introduced some more performance improvements. And then in 2024, Bazel 8 removed most of the still built-in native rules and replaced them by extension rules that are no different from user-defined extension rules, but C++ is still missing. Since then, we've also seen a couple of new build systems coming out, which if you would want, you could call sort of the next generation. So in 2020, the Pants community rewrote Pants version 2 in Rust, primarily targeting Python at the time, and adding dependency inference as a feature. In 2022, Huawei published an interesting project called Just Build, which is a build system focusing on sort of multi-repository projects. And in 2023, Meta published Bug version 2, which is also a Rust rewrite focusing on being extensible and remote first and introducing what I like to call scoped dynamic dependencies, which is good for some programming languages that sort of need modular dependency order builds and things like this. All right, so let's go through some of the features that these systems offer. So I said extensibility is an important thing that we want to have. Most of these systems can be extended in a language called Starlark, which is a Python dialect. It's not true for all of them, but most. With that, you can write your own build rules that look the same in build files as other rules. It provides these features that we spoke about earlier. So cross-language dependency. You seamlessly can say this Python library depends on that C library, for example. You can directly express code generation steps and have other things depend on outputs of these code generation steps. You have sort of semantic targets, so I can say this generated code now represents a Python library that some other Python component can depend on. And you can also manage your tests in this build system, which will then be treated the same as other build actions and will be cached and all that. And you can also express runtime dependencies. So for example, if that golden test input file changes, then we don't have to rebuild the test, but we have to rerun the test. Then being distributed is an important feature, right? So we said to be able to horizontally scale to large code bases, we want to have distributed builds. And we also want to have a shared cache to be able to share build artifacts between developer machines and CI machines and things like this. And most of these systems use a common API called the Remote Execution API, for which you find many open source and commercial systems available that you can use. Most of these systems also have very good support for cross-platform builds, both in the sense of cross-compilation, but also in the sense of managing multiple platforms within a build. So the developer machine can be a different platform than the remote execution nodes, than the target platform, for example. So an interesting comparison that comes up in that context sometimes, if you ask people what is your build system, sometimes the answer you might get is Jenkins or something like this. Which, depending on where you are on like where your perspective is, might be a strange or a surprising answer. But for some projects, that's the case, right? In order to build this thing, you actually need the entire CI pipeline. Otherwise, you're not going to get a built artifact out of it. So it's a fair answer. But it has some issues, which is that it provides a slower feedback time, right? If you need the entire CI pipeline to actually build your project, then as a developer to test something, you have to push it to version control, like to the source control system, trigger CI, wait for the build, get your feedback, which is a bit slow sometimes. So ideally, we'd really want to be able to locally interact with our build system and get the feedback directly within our terminal. Now you might say, well, with a CI system, of course, you can handle much more complex things like multiple platforms and multiple build nodes and things like this. But that's the nice thing with the remote execution feature, right? You can locally interact with your build system, and then under the covers, it talks to remote execution system, which can involve many, many build nodes, which can also be on different platforms. So you could, develop on a Mac and have build steps happening on Linux, Mac, and Windows, and get some artifact out in the end. And then, of course, correctness is a big focus for these build systems. So Bazel, famously, for example, has the tagline "Fast and correct, choose two." And the argument that's being made there really is not so much that they are trying to be fast and correct, but it's that they're being correct in order to be able to be fast, right? So the keyword that is often used there is hermeticity, meaning that your build actions are isolated, so that the build system can enforce that the dependency declarations you make for your build are actually complete and actually correct. And it isolates the build actions so that they simply fail if it tries to access a dependency that you didn't declare. And having these correct build definitions then enables the build system to very aggressively distribute and cache your build actions, which allows them to be fast. And then in that context, most of these systems also enforce explicit dependencies, so that brings you a explicit target dependency graph that you can also use for some static analysis. So you can statically query your build graph without actually having to build a project to know what depends on what and things like this. With a bit of an asterisk, so as I mentioned earlier, PANS2, for example, has inference, and Buck2 has a sort of limited notion of dynamic dependencies. Now, of course, many of these build systems are designed for monorepo use cases, right? So I'm not going to go into the whole monorepo versus polyrepo project here. Catch me later at the bar. That's a separate talk. Suffice to say that most of these systems support some notion of external dependencies, so you don't necessarily need to actually check in everything into your repository. And having many different components across many different languages in the same project with the same build tool provides you this unified and consistent interface and tooling as a developer to interact with the language with targets across languages in the same way. And it kind of puts CI at your fingertips, right? So if you want to test the backend and front end together, you can do that with a single command, which is a nice feature. All right. So if you want to go this route and have a scalable build system, which one should you choose? Well, it's an evaluation that you have to make based on the features they provide. I will say that Bazel is by far the most mature with the largest community and ecosystem at the moment. But the others are worth a look depending on the needs that you have in your project. So for example, with Buck2, I mentioned the dynamic dependencies feature, which is useful for some languages like Erlang, OCaml, Haskell, these kinds of things. Or PANS with a strong focus on Python might be an interesting consideration for a mostly Python project. And then very briefly, if you want to migrate to such a build system, I would say start with first understanding what you actually have and what the pain points are that you want to address, and making a plan. Plan for an incremental build that's incremental migration that's gonna last for a while. So plan to support your old and new build system in parallel for a while. Measures throughout, both in terms of speed and in terms of the pain points that you're trying to address, and make sure to communicate and support your teams throughout, and know that there is help available in the open source community and also with product and service providers. All right, some references. The slides are going to be online or are online at that URL. So thank you very much. I think we have maybe some time for questions, if there are any.
No question.
Yeah. Otherwise, catch me at the bar.
Thank you very much.